All right, continuing with 3.3. So we just talked about the 5-number summary. The 5-number summary is the minimum, the first quartile, the median, third quartile, and then the maximum. So what a box plot does is it just basically shows you that information in the form of a picture and kind of gives you an idea of what does the spread look like in each quarter of your data, right? Bottom quarter, second quarter, third quarter, fourth quarter, okay? So here's a description of what it looks like. It's a graph of the data set that consists of a line extending from the minimum value to the maximum value. And then in the middle somewhere you have a box with lines drawn at the first quartile, the median, and the third quartile. So let's see what that looks like. The way that you construct it is first find the 5-number summary, like we did in the last example. Construct a line segment. I like to think of this as a number line. And then construct a box extending from first quartile to third quartile. And then there's going to be a line somewhere in the middle at the value of the median. Okay. All right, so here's the same example that we already found the 5-number summary for, so that's nice. Hopefully somewhere on here I have, I'm sure I have it. Okay, all right. So there's the 5-number summary that we just found in the last example. The minimum was 0.8, the first quartile was 7.9, median was 13.9, third quartile was 21.5, and then all the way up here at 77.8, you have the maximum, okay? So the way that I actually like to do it is, I'm just gonna add a little something to this. Hopefully it won't look like too much of a mess. I actually like to put a number line below this, and I do that first. Not a very straight line, sorry about that. So this would be 0, and I guess 10 would be right about here. This would be 20, and then I would continue 30, 40. I think that's a good thing to do beforehand, because otherwise how would I know to put 77.8 here as opposed to like here or way over here? Okay. So 0, 10, 20, 30, 40, 50, 60, 70, 80. So that turned out pretty well, except for the crooked line. Okay. All right. So you see your box. The box goes from Q1 to Q3, and it has that line in the middle at the median. And then the lines that come out from the box, which are also called whiskers, extend down to the minimum value and up to the maximum value. Okay, so one nice thing about a box plot is that you can use it to identify skewness. Hopefully you remember we talked about skewness. I think that was in chapter 2. So, you know, a nice symmetrical distribution is not skewed at all. But if you have a few unusually high numbers, that's called skewed to the right. And if you have a few unusually low numbers, that's called skewed to the left. So your distribution of data is skewed if it is not symmetric. That's the same definition we talked about before. So let's just go back to the one we just looked at, because this would definitely be an example of a skewed distribution. The bottom quarter of this data only goes from 0.8 to 7.9. So that's a range of less than 10. The top quarter, on the other hand, extends from 21.5 all the way up to 77.8. So this distribution is extremely skewed to the right. Okay. If I were to make say a dot plot of these values, you would find, I mean, just by looking at them, the vast majority of them are between 0 and 25. And then you just have a few of these really high ones, and they would stretch the shape of the distribution to the right. Okay, so this distribution skewed to the right. Now, So that's a box plot, and then there is also something called a modified box plot. What modified box plots do is they identify outliers. Okay? So here's a definition of outlier that you haven't heard before, I don't think. And it's based on the interquartile range. I think I remember in the last video, there were a few different calculations you could do with the quartiles. And I mentioned that the only one I think I ever use is this interquartile range. It was listed first. So the way that you identify these outliers is you calculate the interquartile range, also known as IQR, which is the third quartile minus the first quartile. So what that is, it's the range of the middle 50% of the distribution. Okay? Then you calculate 1.5 times that number. And for purposes of a modified box plot, we're going to define an outlier to be anything that is either this amount above the third quartile or this amount below the first quartile. So anything that's this amount above the third quartile would be considered extremely high. Anything that is that amount below the first quartile would be considered extremely low. Okay. So let's see if they did, yes. So are any of the values in the previous example outliers? I think I might have added this slide. That was a long time ago, I barely remember. So the interquartile range is 21.5 minus 7.9, which comes out to 13.6. You calculate 1.5 times that, it comes out to 20.4. So an outlier would be anything that is either less than the first quartile minus 1.5 times the IQR, which would be 7.9 minus 20.4. That comes out to negative 12.5. And obviously there were no values in this data set that were negative. So there are no outliers, but high outliers would be anything greater than the third quartile plus 1.5 times IQR. That would be anything greater than 41.9. And we did have a few of those. We had 4 of those. That's kind of unusual to have that many outliers. Okay, so what you see behind me over here is called a modified box plot. And the way that you do the modified box plot is you indicate your outliers with special symbols like asterisks, stars. So the solid horizontal line only extends as far as the minimum value that's not an outlier and the maximum value that's not an outlier. Okay. So we found in the last example that these 4 values were outliers. And you can go back to the set of data and check that the last value before this 43.0 was 38.5. So from here up to here, the box plot looks exactly the same as it did before, except I'm going to stop this whisker at 38.5, and I'm going to indicate all of these outliers with stars.